Today we're gonna talk about our advances in metaprogramming. And so without further ado, let's see what we have in stock. So what is Scala Meta? I've been giving talks about Scala Meta for 2 years already. And every time when writing slides, I feel kind of uneasy. So on the one hand, if you go to the website of Scala Meta, it says that it's convenient, robust, easy to use metaprogramming framework, but that doesn't sound very exciting. So now I'm just going to give a few explanations of what Scala Meta is, and you pick the one that you like. Well, first of all, Scala Meta is a dream. It really started as a dream to make metaprogramming easy for everyone, because by that time I've been working for a few years on macros and on Scala Reflect, and I've seen the pain and I've endured it, but I didn't want to inflict it on anyone anymore. So Scala Meta was born from our collaboration with Dennis Shabalin and our desire to make this thing easier so that no one has to suffer. Also, Scala Meta is something real, so it's not just a dream, it's not just an academic project, it's really a very active project. So as you can see, the project is a bit more than 2 years old, and we have several thousand commits there. So it's very, very real. We will see later on more examples on that. Also, Scala Meta is a community. So I typically do the credits slide in the beginning of my talk, but today when I was preparing it, the list of people, it just didn't fit into the slides even if I used 2 columns. So I've been really, really lucky to have a lot of people on board, and with every person there on the list, we have a story. So there are people from EPFL, our master students, our PhD students, and there are external contributors who just got interested in the project and decided to do something for it. So it's quite exciting, and I invite you to join us if you like what you hear. Also, Scala Meta is a product. So speaking of things being real, it's something that you can execute. So you take this jar, you download it from Maven, and you get to do interesting and exciting stuff. Later, we will see what exactly this amounts to. And finally, I'm really happy to say that Scala Meta is officially endorsed. So I'm really happy that I convinced Martin that Scala Meta is a good idea, and it was very exciting to see the slides during his keynote the day before yesterday. All right, so let's see what Scala Meta is capable of. So what's it good for? A year ago, at Scala Days in Amsterdam, I announced that we've done a lot of experiments. We solved almost all problems that Scala Reflect had. We have prototypes for everything. And now we have to put this stuff on hold and really push for the stable release so that everyone can enjoy the fruits of our labor. And now, a year after, 3K commits and 19 milestone builds afterwards, we have published our first beta release. It's a very exciting day, and we do plan that 1.0 will follow shortly. So what's in there? What do we support in the 1.0 release? So currently we're feature complete, and I'm not going to implement more stuff. Let's study what's there in stock. Well, if I were to find a single word that defines what's implemented there, so it's basically syntactic KPIs. With the current release of Scala Meta, it's possible to parse code written in various dialects of Scala. Scala 2.10, Scala 2.11, Dotty, and obviously it will be easy to support Scala 2.12 and other evolutions of Scala. We also have quasi-codes to have feature parity with Scala Reflect, and might I say that they're quite better than what we have currently in the production compiler. And finally, thanks to tokens, later we will get to see what that is exactly, we can finally have formatting, preserve, and pretty printing. So if you are working with the code, it obviously is going to contain some formatting. It's obviously going to contain comments. So right. And we've got this handled. Okay, so what's next? After we deliver version 1.0, which I hope is going to happen soon, for the version 2.0, we plan to support Semantic KPIs and AST persistence, which means that it will not only be possible to parse code and analyze its structure, but you will also be able to see types, resolve names, do implicit inference, and save all that to disk, so that later on tools can take a look. So that later on we can have integration with this amazing tasty technology that's shipping in Dotty. Okay, now the time has come to take a look at the live demo. So I just want to convince you that the things that I'm going to present, they're real. So I haven't predefined, any aliases, any special configuration of Scala REPL. Let's just go to the website of Ammonite, download the new shell. Wow, that's interesting. And start hacking away. Let's see. It's nice when a project has documentation. That's definitely underrated. All right. Well, while we're waiting, I would like to note that Scala Meta is quite easy to use because all that it takes is a reference to one library and then one wildcard import. Let's take a look. It's going to be load Ivy. Then you say org Scala Meta. Here's this artifact, and here's the version that's currently available. Okay, so see, I haven't pre-cached anything to my computer. It's all downloaded from the internet. Now we're just one import away from having fun. Okay, let's start with something simple. Let's just parse some random code. So in order to take a look, what are the core data structures of Scala Meta and what our abstract syntax trees look like. So let's say we want to perform this very fancy addition. And now once we have the string, we want to parse it into a term. So here we go. No other imports required, no configuration, no nothing. So we were really strict about being convenient. So if you want, you can do much more, and later on I'll elaborate on that. But your first step should be very easy. So now we get this parsed monad. By the way, is everything? Can everyone see the font, or I should increase it? Okay. Is this better? Good. So after we parse the code, we can see the result. We can see that it's a success. And afterwards, we can just get to the abstract syntax tree. So what Scala Meta obviously supports is some debug printing. So we can take a look at the structure. Well, it really contains the stuff that you typed. And I would like to note the difference with what's available right now with Scala Reflect. So here we have a special AST node called apply infix, which models infix applications and lets us distinguish them from regular method calls like this. Okay, here we go. And if we inspect structure of this guy, we will see that it's an apply. So it may seem as a trivial feature because, well, typically as a user, you don't really care whether you write infix applications or not, because the semantics is more or less the same if you don't take write associative operators into account. But as a tool author, so here we have some tool authors in the building, you would definitely appreciate this functionality. And later on, we will have a few examples of tools, real-world tools, which have been built on top of Scala Meta, and which utilize these capabilities to the max. So the next feature that I would like to demonstrate is formatting-aware pretty printing. So let's imagine that we have multi-line code. We have some sort of formatting, say the foo equals bar, and then we write some comment. So I'm intentionally typing something really weird so that you cannot say that our pretty printer is too smart. to figure this out. So here we have the input string. So as you can see, well, indentation is quite off. And now we parse it. We parse it as a term. Let's see what will happen. So right, what happens here is we get to observe how we do error reporting. So as I mentioned, we parse our parse result is a monad, and well, it has two cases: a success case and a failure case. So now we get to observe the latter. So as you can see, we pretty much support the error formatting that Scala C does, and what it tells us here is that, well, we cannot parse this as a term. Well, sure, because, well, here we have a definition. Now let's wrap the code that we have in curly braces. Okay, and I think that now everything's gonna work just right. So now we see that things have parsed successfully, and we see that all the formatting has been preserved. So our weird indentation here, our stray comment here. So how does it work? If we take a look at the structure of the tree, If we take a look at the structure of the AST, we don't see any comments. So what's going on here? Obviously, there's some kind of a side channel through which our pretty printer figures out how the code was written originally. And this is the time when we introduce the concept of tokens. So tokens, they are atomic units of Scala code. Essentially, when the Scala C parser, when the Scala Meta parser processes Scala code, it first tokenizes it. It uses a dedicated part of the compiler called scanner, which splits the input apart into very small parts, like curly braces, like white space. We have a lot of white space here, the def keyword, and so on and so forth. So it turns out that if we don't, so typically what happens afterwards with these tokens after the input has been scanned, these tokens, they get thrown away after the program is parsed. But it turns out that if we do not throw them away, if we reify it and let the users inspect how they look like, then we can preserve all the formatting that we need. So as you can see, if we print out the structure of this tokens collection, then we literally can explore the program part by part, including including all the white space, including new lines, and including the comment. So this is quite interesting, and that's one of the exclusive features of Scala Meta that's well, not always available in metaprogramming frameworks. Now to get to something different, let's try something else. So far we've been parsing Scala, and obviously when we are programming Scala, we're not only using Scala. I'm not talking about Java, which is not supported by Scala Meta yet. I'm talking about SBT. Well, even though SBT files, they look like Scala files, actually they have different syntax. So if we try to take a look at the project that I have here, so I have a bunch of projects. Well, let's see how the simulacrums build.sbt looks like. So, well, it's definitely all very familiar to you guys, but I'd like to note that at some point it was mandatory for lines in SBT to be split by empty lines, so that different configuration parts could be parsed by the SBT engine. And so that's one difference between how SBT and Scala code work. Another difference is that in SBT config files, it's actually possible to write regular terms like vals and defs at the top level, something that you cannot do in usual Scala files. So Scala Meta, since SBT files, they're very important to the community, Scala Meta supports them natively. So let's create this a reference to the SBT file. that we're looking at. So here it is. And now, if just to check it out, just to do a sanity check, if we try to parse it as a Scala source, we will see that it's a parse error. So if we go here, that's all natural. You cannot write method definitions at the top level, not in the default version of Scala. Now let's do the following thing. Let's say that we're going to use the SBT dialect that supports SBT 0.13.6. And now once we imported it, it's an implicit. It will guide the parser to use different strategy for parsing. And now, okay, how interesting. Now that's a surprise. Okay, here we go. So probably this was an SBT build written for 0.13.7 when they relaxed the restrictions on what you can write there. So as you can see, now we explicitly specified the dialect of Scala program that we're looking at, and we got an AST that we can use just as well as if we parsed a normal Scala program. So here we have a source which wraps a sequence of statements, including the import. And well, I'm definitely not going to go through this wall of text, but I would just like to show you that these ASTs, regardless of how exactly you parse them, they look the same and they provide the same functionality. And finally, I would like to finish the tour of Scala Meta by showing quasi-codes. So just like in your favorite macros, just like in your compiler plugins, you can use quasi-codes. So say you can define quasi-quote, which represent an identifier foo, and then you can use another quasi-quote to insert it into a bigger tree. So nothing special, and this is exactly the same result as if you have parsed the code. So pick your own way to work with Scala Meta, and well, just the last thing that I haven't shown, you can use quasi-quotes to deconstruct ASTs as well. So if we match this tree, we get the syntactic parse here. And the very last remark on the data structures that we're using, as you've seen, our data model is more precise than what's typically expected of macros. So as you can see, the type of this y, it's actually not a term, which you would think it should be. It's actually an argument, which means that in Scala Meta, we model really, really small peculiar details of Scala syntax, which are quite unobvious at the first glance and are easy to overlook. So here we are actually accounting for the fact that y is an argument, so it can be a by name argument, or for instance, a var arg. So that's the kind of precision that Scala Meta provides, and I think it's a good thing. Because after making a lot of stupid mistakes with macros and helping people out with this stuff, I really think it's going to be valuable. All right, so let's get back to the presentation and just sum up what we've seen. With Scala Meta, with the current stable version, it's possible to parse Scala sources, both written in Scala and in various dialects. So I can probably show you this here. So we have this concept of dialect which captures differences between, say, Scala and Dotty, Scala 2.10 and Scala 2.11. For instance, in Scala 2.10, it's illegal to use to write dollar splice in patterns, but in Scala 2.11 it's possible. So we're really looking into this very small detail, so that you don't have to bother yourself with that. And then below, here you can see we're declaring a bunch of objects that capture this information. So for instance, in Scala 2.10, if you're writing a var arg pattern mesh, you use an @ sign, whereas in Dotty you use colon. And Scala 2.10 does not allow dollar underscore and, well, this kind of stuff. So we're modeling things really thoroughly. All right, so that's the first thing that we've seen. We also have quasi-codes that provide static type safety. And finally, our pretty printing respects formatting comments by using tokens. All right, what about macros? By now, you might be thinking that, well, Eugene is a macro guy, right? And he gives a talk, and he didn't even say macro in the first 20 minutes of the talk. What's going on? So is there some sort of a, dark secret here? And well, as Martin can say, macros are dead, so nothing to talk about. So here's another screenshot from the slides. Well, macros are going to be dropped from Scala. Well, right? Because they're kind of hard to write. They don't work well with tooling. I think that neither of the popular IDEs can handle them correctly in 100% of the cases. And they're very entangled with compiler internals because Scala Reflect, the current API for macros, is built on compiler internals. Well, they're stats, sure, but also macros are great. We all know that with macros you can do things that wasn't possible before. Take shapeless, for instance. It's a very, very cool concept of generics that has been encapsulated in a macro, and now people can reuse it even without knowing that it's been implemented on top of macros. That's quite a great example of capturing some really, really cool and advanced features in a good encapsulated box. And I'm really glad that macros are capable of that, and that they help the Scala community in that regard. And also, well, you please don't believe me. You can just check for yourself if you go to the website of Lightband and see the offering of the reactive platform, the libraries that are there. Well, most, if not all, of these libraries they either tried or are currently using macros. And well, I think it's quite a good point that macros are valuable to the community. And finally, I think all the points that we covered here, it's actually incidental complexity that's caused by how we implemented macros, not by the very concept of macros that comes from this project. So, well, macros are dead. Long live macros. Let's see what new future we actually envision for them. Well, actually, today I published the SIP that we've been working internally on for quite a while, together with my colleagues from a PFL. And well, you're very much welcome to take a look. Later on, I'll tweet a link about this. So, if you see what's in there in the address bar of the browser, then it's all cool. But later on, I'll show the obvious link. So we've been thinking really hard how to capture the essence of macros that have made them really, really popular and very useful to all the people, as we've seen. And once we started getting to the bottom of it, we actually discovered that macros, they're not just one concept, but they're two concepts hiding behind this one language feature. So actually macros do two things. If we take a look at well, an example macro that back then convinced us to add macros to the language, the language integrated queries macro. So let's just give a bit more background so that we all understand what's going on. Here we have a table class that represents a database table, or well, a table in any data source for that matter. And in that table class, we can define usual collection methods like filter, like flat map, and so on and so forth. And then we can turn these methods into macros, so that queries that people write, they're captured by the macro and then can be converted to SQL queries, or to whatever you prefer. So just to sum it up, if the user writes a call to this method, like here above on the slide, then actually macro expands. The compiler calls the metaprogram that we've written on the previous slide. It expands and inlines the result into the call side. So we see that there are two distinct aspects to macros actually. The first aspect is metaprogramming, is execution of programs at compile time using compiler APIs. And the second concept is inlining. So our current proposal, it actually distinguishes these features. And well, this gives more capabilities, and this gives more refined look to the language. So I guess this goes along the lines of Martin's general idea for Dotty, to make the language more streamlined and simpler to use. So this is a sketch of how new macros look like. So in our draft proposal, we go over that in more details, obviously. But here, let's just take a look at the small example. So we see that the method that we've declared as macro previously is declared as inline. So this captures the inlining part of the current macros. And then at the right-hand side, you have the meta block, which contains the metaprogramming that's going on. So here's what happens when the compiler tries to process a program that has a call to map. So at first, we do the first transformation. When we call inline methods, we just take the right-hand side of the inline method, this block that was written here, meta, braces, and some stuff, and we just inline it into the call side. And this is what we do with inline methods. Nothing else, no other magic, no macros involved at all. And then, when the compiler sees a meta block, then it calls into the metaprogramming world. And well, as you can guess from the name of the block, the stuff that's going on there, it's implemented in Scala Meta, of course. And so when the evaluation completes, when this quasi-code gets computed, then finally you inline the result into the call side. So this is the refined view of macros that we've expressed in the public draft of our proposal. And if you're interested in that, if you find that it's useful, or if you find that it's not quite there yet, please take a look and leave comments. All right. So another demo. Actually, I didn't plan to give that one, but yesterday, when we met with Martin in the morning, so I told him, "Please, Martin, come to my talk. Well, how can I, convince you to do this?" And well, I had to bribe him somehow. So I told, "All right, I'm going to implement these new inline macros, inline macro notations. So please, Martin, come on in and take a look whether it will be possible, whether I manage that." Well, as a matter of fact, I did. After 14 hours of hacking, it wasn't that much. I even got some sleep, actually. And now I'd like to present the results. So I hope that this practical evaluation will convince you that the split between inlining and metaprogramming is actually a good idea. Okay. All right, so this is how this looks like. As I promised, there's an inline method with a meta block, and now we're gonna use this concept to express macro annotations. So this is the replacement for the app trait that was removed from Dotty, as Martin said, because well, this feature delayed in it wasn't carrying its weight. And now we're gonna replace it with macro annotations, making the language simpler and more streamlined. So what's going on here when trying to think how to think about macro annotations? I took inspiration from Python's decorators. So how we can treat this notation that we're seeing here is as if we are calling the main method, passing it no arguments. So I don't know, if we wanted to pass some argument here, main of 42, we would do that, but it just doesn't make sense. And then we also pass it a block where this object test is defined. So now, if we declare this method called main as inline, then what's going to happen? Well, this will be a call to this method. It will be replaced to some sort of a meta with some sort of a meta block, which will expand and produce the desired result, which is well. What do you expect? No, it doesn't support this. Well, this is pretty much straightforward. I don't think that was a surprise for you. So that's what we want to achieve. And let's see how Inline and Scala Meta can help us do that. The implementation is actually trivial. So as I said, we model macro annotations as methods that may or may not take parameters, and they also take the definition that they annotate. So in the meta block, what happens? We destructure this definition, this defin, using pattern matching with quasi-quotes, and it's again a really interesting aspect of Scala Meta. It forces us to be mindful of very small language features, like early initialization or self-types. So do we want to allow early initialization in this new app, in this new replacement for app? That's a good question, and I think it's good that Scala Meta forces us to think about this. So then we take the stats that we've extracted, and we just put them into the main method. And finally, we replace the body of the object with this method. So that's just one of the strategies of implementing the new main annotation. And of course, with Scala Meta, it will be possible to do whatever you want, to just take this code apart and reassemble it how you see fit. So it's very easy to experiment with language features and to see which strategy we would like to pick before hard coding it into the compiler. So now the mandatory demo, so that we get to take a look how it works. So just to make sure that we're compiling the right thing. Here's so my Scala C thing is actually an alias that calls into the Macro Paradise plugin and links to the Scala Meta library so that we can make use of this Scala Meta import. So once we compile this macro, it will think for a while because well, we're running on the JVM. How cool would it be to have the Scala compiler compiled using Scala native? So definitely the startup time and compilation times for simple applications, I hope that they will improve. I know that Dennis is not gonna promise anything, but I'm just keeping my fingers crossed. Still a very, very exciting possibility. I mean, this guy he's very passionate about startup time, so I know that my trust is placed rightly. Okay, so we've just compiled our macros, and it's time for us to compile the test file. So we provide, well, the class path is handled by the alias. Well, actually, we can just get a sneak peek of the code that gets generated. Here's the secret option that allows us to do just that. So we insert ourselves after a certain phase in the compilation pipeline, and we actually get to see that the code is exactly what we needed. Finally, just to verify that I'm not cheating you, we just run the compiled files and get the mandatory hello world. So, all right, this shows that you can do quite a lot of stuff in 14 hours if you have Scala Meta, of course. Without Scala Meta, it wouldn't have been possible. All right. And in the meanwhile, Martin wasn't also idle. It turns out that he submitted a pull request that enables the foundation for macro annotations in Dotty. And if we take a look at that pull request, because it's quite particular, I would like to tell you. Okay. So we can see that one file has been changed and just one line has been moved around. So how cool is this, right? Because, well, I can tell you, it took me much more than 14 hours to implement macro annotations for Scala C, and well, Martin did that in one line of code. I think this is a testament of how cool Dotty is. And the commit message. No, that's just cheating, Oh, there is a commit message, This was surprisingly easy. Congrats, Martin. Okay. What else do we have? Now that we've talked about the present, let's briefly talk about the future. What's there in the future of Scala Meta, and how does it look like? Well, I would like to talk about several of our users. Even though our version number is currently starting with 0, and until today it was starting with 0.0, which is quite weird, we already have users. That's amazing. So first, I would like to talk about Codacy, a code analysis startup. Oh, they've changed the UI. That's neat. And now we're gonna log in. It's great that we have internet. And try to see what code patterns that they provide. So actually, this is not quite what I want. So actually, Codacy, they do a number of code analysis on projects that they fetch from GitHub. And among the languages that they support Scala. So these code analysis, they're implemented with patterns. And well, there's a bunch of them. Some of this code analysis, they're built on top of Scala Meta. And we're just gonna take a look at how this works. So they've actually built together with Mathieu, one of our master students. They've built this great UI and this integration of Scala Meta into their platform. So to the right, I don't know whether I'll be able to increase the font much. So can you guys see that? All right, cool. So to the right, you can see code that uses Scala Meta in order to find certain undesired patterns in the code base. So here we're looking for, option.get or either.get. So if you think that this pattern is naive, it is a little bit, and I'll talk about that later. But let's see what's going on here. So we see that this quasi-code, q of something.get, it detects calls to option get methods or either get methods. And then on the left-hand side, you have your test snippets. And then you can take a look at the messages that are produced in the diagnostic. So I think it's all quite neat, and I'm definitely happy that Scala Meta is used for this. One of the reasons was the comprehensive data model for ASTs that I've been showing off recently. So it's not some academic exercise, some academic curiosity, but actually it's the exclusive feature of Scala Meta that this rich model of the Scala language is available right now, and it's so easy to use. So that's one use case. Another use case is a more recent user of Scala Meta. Olaf, one of our master students. So Olaf is currently writing his master thesis, and for that he did a very cool tool that's called Scala FMT. So recently he gave a talk at FlatMap about that. And what this tool can do is take a source file, parse it with Scala Meta, take a source file that looks like a mess here, parse it, and then reformat it automatically to conform to some chosen style. So I won't go into details because Olaf has given a big talk about that, and I think they've published videos yesterday. So if you're interested, just Google Scala FMT and FlatMap. I really recommend looking at this. So it's a really cool project that shows that next generation tools they can appear if we have the right foundation for that, which is Scala Meta, of course. All right, so we have Codacy, we have Scala FMT. We've seen how you can build inline macros on top of Scala Meta, and finally, this is something that should be familiar to you from yesterday if you attended the talk of my colleague Dmitry. So there's this cool tool called Dotty linker, which does whole program optimizations for the Dotty compiler. And recently, the feature that Dmitry recently introduced is rewriting rules. So it's possible using the technologies that the linker provides to specify certain patterns and then rewrite them into something else. So here, the match with Scala Meta was pretty obvious. So it's possible to take a pattern and then to run some custom code to do metaprogramming to produce the result. So please take a look at the slides of Dmitry's talk.
The talk was called Precise Types Bring Performance. Dmitry has already published the slides, and please ask him if you have other questions. All right, so now to not so fun stuff. It's a really great picture from PhD Comics, a website that I frequent. Well, actually, if someone has been around for the 5 years history of the Scala Meta project, they may remember that it was my beginning of the PhD thesis at the PFL under the supervision of Martin. And well, 5 years are almost over, and I must graduate. So I should write a thesis, wrap up, and then jump to industry, write, I don't know, some applications in C# and Java, and never see Scala again. So what's going to happen with all those things that I presented? Is Scala FMT going to be canceled? Are macros really going to go away? So, well, actually not. This winter, I was thinking what to do next and how to continue the projects that I'm really passionate about, macros and Scala Meta. And I approached different companies. And ultimately, Twitter, they made me an offer that I could not refuse. So later on this fall, I'll be continuing the stuff that I was doing, doing my open source development, partially sponsored by Twitter. It's a really cool arrangement that we arrived at, so that I'll still be able to do open source development during paid time. And so, as a result, just to sum it up, so the project is officially endorsed. It's alive, and thanks to Twitter, it's also funded. So I think it has a bright future, and we have users, and we have really cool features. So please try it out and approach me if you have more questions. Thank you. All right, I think we've used most of our time, if I'm not mistaken. So I can take one question maximum. All right, please.
Can you briefly describe the semantic KPI you have in mind for Scala Meta?
So the question is, what are we going to add in Scala Meta to what kind of semantic API we have in mind? Well, at the moment, it's things are still in flux, so I wouldn't want to promise what will change and what we cannot deliver. But the main idea to have feature parity with Scala Reflect. So with Scala Reflect, you can resolve names, you can list members of a given type, you can see type signatures of methods. So this is the basic stuff, and almost all of that is used by tool authors, by macro writers. So I think it's imperative that we leave this in. So I think another killer feature of Scala Meta is ST persistence, that it'll be possible to take these trees with all the semantic information, with all the types and all the resolved names, and then save them, so that later your tools or what have you can inspect them. So that's basically the short overview of Scala Meta version 2. Okay, on this optimistic note, let's finish our chat, and thanks a lot for coming.